Hey there, it's Dina from IDon'tGetItTutoring.com. In this video, I will be explaining geometry basics. Everything you need to know when you start geometry will be covered in this video. Let's get into it. So, geometry has a lot of vocabulary that, if you don't really know what it means, it could be really confusing. You might have no idea what the question's asking or what the answer would be if you don't know these terms. So let's just start with the absolute basic. A point. What's a point? So a point is a part of space. Just a single location in like all of the space. Just a single location, a single point, single location. And then when you have another point and you connect them, that was a really bad connection. Let me make this a little more fancy. Okay, straight enough. When you connect 2 points, that's a line segment. Notice how I say segment and not just line? Because a line segment is when you can measure its definite length, meaning it's part of a line, because a line goes on forever and ever and ever. It doesn't stop. It just goes infinite in both directions, hence the arrows, because it means that the arrow shows that it's going to keep going. So line is infinite, the line segment is finite length. Now let's say there's a point on one side and then you just have an arrow on the other side. That is a ray. A ray is where you start somewhere and then just keep going. You can also not measure the length of a ray. It's infinite. So that's the difference between a ray, a line segment, and just a line. So let's say we have a bunch of points everywhere. Actually, let me make this a little cleaner. So let's say we have a bunch of points in space on a plane, just like scattered and everything. But these three are connected. These three lines are collinear. Not these three lines. These 3 points are collinear. Together, that means they lie on the same line. The points are collinear. You cannot say a line is collinear. Points are collinear. So when points are collinear, like I said, they lie on the same line. These points that are left are not collinear because they're not on the same line as these other 3 points. They are not collinear with these points. Okay? So that's the way you should use that vocabulary. Okay? You have to be very careful not to say lines are collinear because then you're just not going to make any sense. So let's try a little example with this now. I'm going to make some points. I'm going to label them. So that's A. This is B. This is C. This is D. This is E. And this is F. And I'm going to make a few lines. That should be straighter. I'm going to make a few line segments. Okay. Okay. Which points are collinear? C and F are collinear to each other. C and E are collinear to each other. And A, B, and C are collinear to each other. A is not collinear to E. B is not collinear to F. But C is collinear to A, B, E, and F because it lies on the same line segment as each of them. Okay? So C is the common point that they all share. Moving on, let's get into circles. So I'm gonna try my best to make a perfect circle. Oh, actually, I'm gonna use one of these shapes here. Oops. Okay, so we're just going to keep this circle the way it is, a little bigger. So this is a circle, and in its center, guess what that's called? The point in its center. You guessed it, that's the center. That's the center. It's as easy as that. The point in the middle, that marks the absolute middle of the circle, is its center. Now, there is a distance from one end of the circle to the other in the circle that passes through the center. This is called the diameter. The diameter is the length of the entire circle. However, the radius is only half the diameter. The radius is the length from the center of the circle, to the outside of the circle. On the other hand, the diameter is just from one side to other through the center. So another thing to just keep in mind, because it's useful to know, the radius is equal to half of the diameter. Another way to write this is r equals d over 2, or d equals 2r. Those are some useful formulas to just keep in mind when you're dealing with circles in geometry in more depth. Now let's get into angles. So this was circles. And back there, we had covered points and lines. And now let's move on to some angles. And make sure to spell angles, not angels. I've seen kids spell angles like angels. You do not want to spell angels. That's not a geometric term. And you could get points taken off for that. So, silly, but some kids actually do that. So please be careful. So yeah. What is an angle? I'm sure you've heard the word before. An angle kind of looks like this. Or it could look like this. Or actually, it could even look like this. So, an angle pretty much is when you have two rays, right? Because we said a ray has one point and then an arrow on the other side. Two rays connected at the same point, and then we measure the distance in between them. Moving it by 1 unit, that's a degree. A degree is a unit of measurement that we use for angles. For example, we have angles with a certain degree measure. So, when we have an angle that has a measure of 0 to less than 90 degrees, that's basically when an angle has a measure less than 90 degrees, that is acute. That is an acute angle. Way to remember it, small, cute. It's a very cute angle because it's so small. Next, we have angles that are greater than 90 degrees, like this one. This is an obtuse angle. Obtuse people are usually called stupid because they're big and bulky and whatever. But that's a way to remember it. Obtuse, big, blue, dumb, something like that. Right angle is 90 degrees exactly. They usually are marked with a little box or like a little square, and that's because squares have 4 right angles. So basically, when you'll see it marked with like a little square like that in the corner, it's showing it's 90 degrees because it makes the corner of a square. And now finally on to the last one. That is a straight angle. A straight angle is equal to 180 degrees. Another thing I want to add is an obtuse angle is not only greater than 90, it's greater than 90, but it's also less than 180. So actually, let me fix that right now. Because there wouldn't really be, okay, yeah, so it's 180. Yeah, so basically the angle measure needs to be between 180 and 90, and the notation for the measurement of the angle is measure of angle A, for example, because people usually label angles based on the center point over here. So if this was point A, this would be angle A, okay? Oh, and now that we're still talking about angles, I want to mention how to label angles and use like what to call them when you're talking about them. So let me draw another angle right here with 3 points. Okay, so we have A, C, and B, points A, C, and B on this angle. So what are we going to call the angle? We could call it angle C, right? Because that's the point on the vertex of the angle. But let's say we have something like this. Is it still angle C, this one? But what about this one? Wouldn't that also be called angle C? That's where it would get really confusing, because then technically with that rule, don't 2 angles have the same name? No. Technically, if the angle's by itself, just like this, without being connected to anything, you can call that angle C. That's completely fine. But if you have 2 angles connected, like in this example, you are going to label the angle based on its points. And that's going from 1, 2, 3. Okay? Meaning outside, middle, outside. So this angle is either angle ACB or angle BCA. Do not put the letters in alphabetical order. This is not angle ABC. That is incorrect. Angle ABC would look something like this, because B would be the vertex. So that is incorrect. Do not put the letters in alphabetical order. Put them in the order they are showing up as. And then I want you to try this angle right here, the second one that I just did in green. I'll give you a second to do that. Feel free to pause the video if you need a little more time. I'm going to start now. So this would be angle BCD, right? BCD, or angle DCB. Both are acceptable. This is not angle B. Oh, actually, you could put them in alphabetical order, but this is like a rare exception. Do not put your angles in alphabetical order. This cannot be angle D or BDC. That is not one of the possible things you can call your angle. Now, when angles are connected to each other, you need to know what they do and their properties. So let's say we have a right angle and then we have another ray inside of it. And these 2 angles equal to 90 degrees. These angles, when 2 angles, their degree, when the measure of 2 angles adds to 90 degrees, they are complementary. You have to okay, complementary. The Y didn't fit, but it's complementary. One word. Complementary. But when the angles add to 180 degrees and they make a straight angle, like two right angles, that is supplementary. And you need to know the difference between complementary and supplementary because there is a big difference between them. If you mix them up, you can get to completely different answers. And if you're wondering, well, what if two angles add up to 100 degrees? There isn't really a name for that, unfortunately. We just have specific ways to signify if they add up to 90 or 180 degrees. Otherwise, they would explicitly state in the problem what the exact degree measure is that they add up to. Now, if we have two angles of the same measure and they are equal, so let's say this angle right here is 30 degrees, and then this one also is 30 degrees. These angles are congruent. Their measures are not congruent. But they're, like the angle itself is congruent. So instead of saying equal, actually, I made a mistake. Ooh. Over here, that's congruent. So when you want to signify something is congruent, you use the symbol. It's a little squiggle and then straight. So it's like an equal sign, but you just make that little bloop on the top instead of two straight lines. So you can't say two numbers are equal, congruent to each other. Congruence is for geometric objects such as a triangle, for example, or an angle. If you're wondering about triangles, two triangles are congruent when they have the same side lengths and the same angle measures. Something like that, or something like this. These two would be isosceles if that was the case. And if this is something the case, this is also congruent. And if it was like what I had shown before, where it was only one on each side, that would mean they're equilateral. Yeah, I know, a lot of stuff thrown at you, but we have more videos on that stuff on our I Don't Get It Tutoring website, so feel free to check those out if you have more questions. Yeah, so that is congruence. Now, more on angle properties. I know I'm talking so much about angles, but they're a huge thing in geometry. So let's say we have an angle pair. Well, let's say we have two lines, right? When they intersect, there's many ways you can interpret their intersection. If they make a right angle, that means they're perpendicular. When two lines are perpendicular, every single angle they make is a right angle, 90 degrees. You can make a square. That's perpendicular. When two lines never touch, that's parallel. Parallel lines have the same slope, but a different y-intercept. More on that in a different video, if you feel free to check that out. Now, let's say two lines intersect, but they don't really have a specific degree measure. It could be something random like 110 and then 70 degrees. These angles are called vertical angles. So vertical angles are when you have so basically set like these two that I just marked, those are vertical angles. Vertical angles are across from each other from two intersecting lines, and those angles are congruent. They're the same measure. So and then the 110 angles are vertical angles and congruent as well. Now on to parallel lines with a transversal. Let's say we have two parallel lines and then there's just like a line cutting through them. That means we have another set of angles. So I feel like I should rotate this to make it easier to explain. One second, bear with me. I don't know what's happening. My thing's glitching. Okay. Okay, so I can't rotate that. That's fine. But I'll just recreate it on the bottom over here. Let's say we have two parallel lines. And then whoosh! A line cuts through it. This line is called the transversal. That's a line that goes through a pair of parallel lines. Now, I'm going to label the angles A, B, C, D, E, F, what am I doing? G, G, H. Now, since these lines are parallel, and the transversal line goes on in the same direction in that same degree, that same angle through both of them, just in a somewhat different location because this one's over here and this one's all the way over here, but that doesn't really matter. These two angles would technically be congruent, as would these to each other, as would these to each other, and as would these to each other. These would be vertical angles, meaning they would have the same angle measure. Let me clean that up a little. Also, let me talk a little bit about interior and exterior angles. Angles inside the parallel lines, which would be these four right here. These are internal angles. The ones on the outside, right here and right here, these are exterior. Okay, so exterior angles and interior or internal. I'm just gonna say interior too. You might see that in a problem. They have special properties. So I went over corresponding angles having the same degree measure, right? So meaning corresponding angles is when it's like on the same angle, just like moved up or moved down. So when you have these corresponding angles like when A and C correspond to each other, that means F and G correspond to each other because they're the same. And since they're the same, technically, A corresponds to G and C corresponds to F. That means they're congruent. Same thing for exterior angles as well. So, alternate exterior angles, alternate meaning on alternate sides, alternate exterior angles, like B and H, they are congruent. And a pair of like G and A, they are congruent as well. Same thing for alternate interior angles. C and F are congruent to each other, and D and F are... Okay, that's an E. I guess the extra line got erased by accident. But yeah, so and D and E are congruent to each other. Now, if you notice, let me just get rid of all this color. B and A make a straight angle. Make up 180 degrees. So when two angles make 180 degrees, that means they are supplementary. So B and A are supplementary to each other. C and D are supplementary to each other. E and F are supplementary to each other. G and H are supplementary to each other. Also, G and E are supplementary to each other. F and H are supplementary to each other. B and C, A and D are supplementary pairs. Okay? Now, even if you were to use the exterior and interior ones, so same side exterior angles are are supplementary. Same side exterior, like A and H, B and G, are supplementary. Same thing for same side internal. Supplementary. Okay? One more thing I would like to add for geometric basics are bisectors and midpoints. That goes back to points and lines. So a midpoint is basically, let's say we have a segment. The midpoint is what splits the segment exactly in half, meaning both sides are congruent. The midpoint bisects, splits it exactly in two, the segment. So a line could bisect the segment. The bisector goes through the midpoint. A perpendicular bisector, meaning a line that is perpendicular to the line and goes through the midpoint. And there you go. So those are all of our geometry basics. I know it's a lot to take in. Look at all these notes. But if you check out our website, we have a whole PDF with all these definitions that I discussed in this video, so you can further study them yourself and go over and see if there's any questions. Of course, if there's any questions, reach out to us at idon'tgetittutoring@gmail.com and we will get back to you. Thank you so much for watching. I hope you have a great day. Good luck.